Alright, folks. So, today we will discuss generic functions. So, to quickly recap, what is a function? A function is a mapping which connects every input that you can give to it. Think of it as a machine. You give any machine an input, it will give you an output. So, whatever input you are giving, the corresponding output is matched, and that is the purpose of this function. It is literally in the name, that is its function, to match the input with the correct output. We had some terminology here. The allowed set of inputs were called as domain. Now, why is there a question of allowance here? Why should I allow some input? Or rather, what are the cases where in certain inputs might not be allowed? For example, let's say this is your function. You can't put x is equal to 0 because 1 divided by 0 is not defined. It's going to be infinitely large, something we cannot comprehend. So it is undefined for us. So wherever you see, denominator becoming 0, those values of x are not part of your domain. What is another example for this? Under root of, let's say, x. If I give it to you like this, you can't put negative value of x here because under root of a negative number is imaginary. It is not defined. As far as our discussion for CAT goes, there are imaginary numbers, complex numbers, but those are not part of CAT syllabus. However, overall in maths, we say that under root of a negative number is not defined because you can't square something and get a negative value. Similarly, log x, you can't define this for a negative x because something positive raised to something can't give you negative, right? So this is what domain was. Then there was range. What was range? The actual values, the actual set of values your output is taking. That is what your range is. So domain connects to the input, the values that you have the choice to put. Range connects to the output, the values that the function can provide to you depending upon what the input is going to be. Now usually the functions that you see most commonly, can any one of you give me an example of any function that you can think of? Yes, so let's say quadratic. You have ax square plus bx plus c. This is your f of x. Now, this is your function and this is your output calculation. You will put the x value, whatever input you want to put, based on what the values of a, b, c are, you will get some corresponding output. This is how functions should generally be defined. And in this way, it is easy for you to predict what the output is going to be. Compare that to generic functions. When the function is in terms of function, for example, f of x is equal to f of x minus 1 plus f of x minus 2. Now, would you agree that finding the output is going to be a bit more difficult? If I say find the value of f of 1, the value of output, the value of f of x at x is equal to 1, you will have to manipulate this. This is an easy example as far as generic functions go, but it will be more difficult than this. Here you only had to put and calculate. You had something which was giving you the exact calculations that need to be done to find the output, which is something which is absent here. This adds an extra layer of complexity for us. Which is why CAT sometimes, not sometimes, very often banks on this. Alright. There is another type of this. Who says that you can only put one value in the input? What if the function is like f of x plus y is equal to f of x plus f of y? You have two sets of inputs here. You have to pick an x, you have to pick a y, and this is what the output is going to be. Output itself is in terms of function again. So this is also going to be much more difficult than this. I hope you guys can appreciate the complexity that we are trying to address here. Yes? Alright, great. So with this opening salvo, let's go deeper into what generic functions are. Now, actually, before we even go into that, there is something that can be done here, right? You had an exact calculation here. If something from the generic function family is given to you, you will not have explicitly stated calculation, formula given to you in the form of inputs. What are your choices? Can anyone tell me what are your choices? If I do ask you, if I give you a generic function like this or this, and I give you, find the output for me, how will you proceed? So there are two ways. Either you convert a generic function to a known calculative function. You are that smart that even though they gave you a generic function, something like this or this, you were able to guess what the function should be. So number one method is guess the function. Number two method is what? There might be some pattern. Maybe cat is cognizant of the fact that because you don't have the calculation given to you outright, it is a difficult question. Maybe they give you certain input output mapping and this function definition, this generic function definition, and they ask you for a very specific value, not a random input value, a specific value which you can hypothetically find by finding some pattern. This is most common. This is also most difficult to do, which is why this topic is something which is feared by a lot of people. I'm sure a lot of you must have faced this sort of difficulty. What is the third method? And you guys have known me for a long time now, and you know what my last method always is. The keyword on the last. Brute force. Just you even here, even in a generic function, you are given a definition of sort. You can start putting values, you can keep on putting values until you arrive at your answer. This is brute force. These are the three things that we can do. We will first cover what are typical functions that you can guess. Then we will go into making this difficult choice. Should I go for brute force or should I go for pattern? And then I will help you identify certain patterns. Disclaimer outright, this is a difficult topic, not to explain, not to understand, but to do it yourself, because the number of patterns that can be possible are going to be a lot. But let's not get ahead of ourselves. Let's proceed. So let's guess the function. Let's say this is the definition which is given to you. F of x plus y is equal to f of x plus f of y. What could be one possible, appropriate guess for what f of x should be? This would work, right? Now, what are the keywords that I said? One possible. There could be a lot more different definitions that can fit here, but the most simple definition. And if we are guessing a function, folks, would we not want to guess a simple function? Maybe there is another alternative here, but if this one gets the job done, then I should try and focus on this one. So f of x is equal to x, a linear function, x to the power 1 will satisfy this. Now, what are certain properties of this? If I put 0, if I put both x or y 0, what will I get? F of 0 is equal to 2f of 0, which means f of 0 is equal to 0. So a function like this must pass through what? The origin. A function like this must pass through the origin. It should pass through the 0 comma 0 thing. Again, obviously you might ask, sir, how are you even defining origin? Because x-axis and y-axis both are inputs. Maybe we take a third axis for the output. So it will pass through 0 comma 0 comma 0 in that sense. This will be an odd function. Now this is where I want you guys to focus. Let's say you're not able to guess what the function is. That's fine. What are some of the smart things you can do? Putting both the values as same and that same value also as 0, it's a smart thing to do. Putting those as 1 and 1, it's a smart thing to do. 2 and 2, 1 and 0, all of these are smart things to do. Can I also put it like x and minus x? Yeah, because this will give you f of 0 is equal to f of x plus f of minus x. You already know f of 0 is equal to 0, which will give you f of x is equal to f of minus x, negative. Where have you seen this? This is an odd function. When I flip the input, when I put a negative number of the same magnitude, the output also flips. So something like this will always be an odd function. Do you guys also notice while we have guessed the function, did I use the function definition to arrive at these results? Did I use f of x is equal to x here? No, right? Let's use that. Now f of x plus x is going to be 2 times f of x. F of x plus f of 2x, which is f of 3x, is going to be what? F of x plus f of 2x, which is what? 2f of x. So can I say f of 3x is actually 3 times f of x? So technically f of nx is going to be what? N times f of x. A highly important result, because sometimes they give you this as a starting point and then you can guess that I can write it like this. This thing goes both ways. Technically, even here I have not used this definition that we made for ourselves. These we will try and use in some questions in the quiz, in the subsequent sectional that you will get. You will have to use this. One more key mistake that a lot of people make is you should not leave this empty. This should not be just x. This should be f of x is equal to kx. Putting this constant will help you avoid all sort of troubles. And can anyone guess what trouble I can run into? Slope is okay, that is okay. The trouble that you can run into is maybe they give you an input output relationship also. Maybe they give you an exact relationship also. For example, they give you this function and they say f of 1 is equal to 3. Now you assumed f of x is equal to x, and then when you put f of 1 you will get 1. You will be confused that you are getting f of 1 is equal to 1, but they have given f of 1 is equal to 3. So cat is wrong. It's a wrong question. No, that's not correct. You are missing this k. And this k value is what you will find using the data point that they have given to you. You need to find the k by using the data that they have given to you. So are we all clear on this? F of x plus y is equal to f of x plus f of y. Alright, great. Then let's move ahead. The second type is f of x plus y is equal to f of x into f of y. What can I guess the f of x to be? This can be an exponential function. Because a to the power x plus y will be what? ax into ay. This is what f of x, this is what f of y, and this is what f of x plus y. Now what is f of 0 going to be? Just put 0. You will get f of 0 plus 0 is equal to f of 0 into f of 0, which will give you f of 0 is equal to f of 0 square. Now, do I have multiple solutions here? You can have f of 0 as either 0 or 1. Now, if you have f of 0 as 0, would this make any sense? Because f of x plus 0 will be equal to f of x into f of 0. F of 0 if I take as 0, this will make this entire side 0 and you will be left with f of x is equal to 0. So then your f of x is always 0 regardless of what you put. So as a rule, because of this reason, because we want function to have different values and not just be a flat line having constant value of 0 everywhere, we ignore this value and we take this one, that f of 0 is equal to 1. Is the explanation clear? Alright, great. Scaling of exponent. Could I write it as a to the power kx? Let's check. A to the power k times x plus y is equal to a to the power kx into a to the power ky. This is same base getting multiplied to each other, so I can make the base common and add the exponents, which will give me the same thing. So yes, I can scale. I should scale. I should write it as a to the power kx. For what reasons? Have we covered those reasons already? Yes, we have. So same reason. They might give you an absolute, input-output relationship, using which you will have to find this k. Can we move ahead? All right, great. Your next is f of xy is equal to f of x plus f of y. What relationship can satisfy this? Log x is f of x is equal to log x. What will I write it as? Log of xy, which because x is getting multiplied with itself and I am taking a log, so I will separate these as addition. Log x plus log y. This is what f of x, this is what f of y. So yes, this definition can satisfy. Now, can I scale here as well? Now, should I take f of x as k times log x or log of kx? First of all, are these two different? Yes. So which one can I take? Let's test both. Let's test both. Let us test this one first. So I am saying k times log of xy will turn out to be k log x plus k log y. This is what f of x, this is what f of y. So this one works. Let's check for this log kx. Log of k into xy is equal to log k plus log x plus log y. Log kx plus log y would have been 2 log k, one coming from each, plus log x plus log y. Are these two equal? There is a difference of log k that you have. So these two are not equal. So this is wrong, this is correct. So you can write it like k log x. You should write it like k log x. Just to address your doubt, do we need to always parallel check domain? You should, because if the if the input output connection that they have given you, it is for a negative x, then this will not be the function, right? And Ritvik, can we not scale the base? You can scale the base, and isn't that what we have technically done? You just take this k downstairs, you take it to the denominator and then bring it inside the log, so then it becomes 10 to the power 1 by k, which is a scaled base. So this is the best representation, which is what we will use now right now. But yes, you are correct. You can always scale the base. Next function, f of xy is equal to f of x into f of y. Power functions. What will you write the function as? X to the power n. And you can check. This is xy to the power n, which will be x to the power n into y to the power n. This is f of x, this is f of y. So yes, f of x is equal to x to the power n holds. That is correct. Now, quickly tell me, is scaling possible here in any shape or form? First of all, scaling n makes no sense. If I write it as kn, you can just replace kn as capital N. How does it matter? So scaling will be of x or of a coefficient outside. So the question comes, should I write it as kx to the power n or kx to the power n? Or none of these. I can only write it as x to the power n. Which one is possible? Let us try this. Let us try kx to the power n. You will get k into xy to the power n. On the RHS, you will get kx to the power n into ky to the power n. Are these two equal? No. Let's try this one. You will get kxy to the power n, and on the RHS you will get kx to the power n and ky to the power n. Are these two equal? No. These two are also not equal. And because of this, the only choice that you have is fx is equal to x to the power n. No scaling possible, which makes this a very difficult question for CAT to ask you. Because anything they give, you will immediately spot that this is a exponent, this is a GP, so to say. Right? So this is a low priority item for us, because CAT also will avoid this. There is nothing there for either them or us. Can we move ahead? Alright, now two very subtle, distinctions that I want to make for you. Guessing the function is fine. You guess a function, you use the given data points. Ensure that this function definition is allowed. You check that, there's no domain issues coming up. You check that whatever the relation they are giving to you, let's say they are giving to you f of 1 is equal to 3. So whatever you have guessed, it is possible for f of 1 to be equal to 3, which will, help you find your k. All of this you should do. Even then, and let's say this does not happen. You guess the function, okay, and you could not reconcile this. So what does that tell us? One of the possible functions, whatever we are guessing, it is one of the possible functions. It is not the only answer, and the reason is derived from this. Whatever function definition that we have taken so far, it is based on continuous domain. That 1 can also be put 1.00001 and can also be put, so on, every value can be put there. Basically, if 1 can be put, then the next smaller value can be put within the domain. That is called as a continuous domain. That you don't discriminate, you don't discriminate between integers and, or numbers based on what they are. It is continuous. Every next value is also allowed. Point domains, however, function something like I say f of n is equal to f of n minus 1 minus 1. And I define this for natural number. Generally, these guessing of functions might not work here. You can also think of it like this. Because the mapping they are defining is for point domains, for natural numbers, whole numbers or integers, they have a way to creatively make a rule so that this comes out to be the output. However, if they give you more choices for the input, they will have to inevitably land at, something generic. So again, it's a word of caution, worth trying. It is worth a try to guess the function. If you are not able to guess the function, don't lose hope. We are going to discuss what to do then. But generally, guessing the function is a good idea when they do not put any constraint on the domain. And when I say constraint, I don't mean that only positive is allowed. Not that sort of constraint. Constraint being that they are not hand picking values for you, which they will do if they put point domains. For these situations, generally guessing the function is difficult. It might not work. Because hypothetically, I can create a computer algorithm which will give me, data points for the answer and avoid the guessed function that we used, because I am only checking for certain hand picked values. I have the choice for that. In continuous domain, they have to satisfy for every possible real number in that domain, which will inevitably lead to you a function that we probably will guess. It's a subtle difference. It's a word of caution. Good to know. So maybe this is something you should look out for when you start solving the question. Again, no absoluteness here. Even for point domain questions, you can guess the function. It might be possible that they made the function like this, that it is actually the guessed function only. But generally speaking, point domain functions are not, guessable, so to speak. Can we move ahead? All right, great. Yeah, so this we have covered. Now, there are certain, general tips. Let's say you are not able to guess the function, right? Don't overcomplicate early. That is your tip number one. Pattern has to emerge. Pattern has to emerge. You owe it to the question to check if there is a pattern or not. So you should focus on finding the pattern first and not fall into writing the values, answers, etc. Observe. Let's say you gave it a fair shot. Maybe patterns are not always possible. Maybe it is a random question, in which scenario it's a bad question. It is not worth asking in a exam like CAT. So less likely to occur, but might happen. If this is a possibility, the other possibility is this: if they ask you for an obnoxiously high number, you have a greater certainty for a pattern. And you understand, right? If I ask you for f of 1000 and I give you some relationship, would I expect you to find f of 1, then use that to find f of 2, then use that to find f of 3, and so on till 1000 in an exam like CAT, where you have 2 minutes per question? Which means there has to be a pattern to make this question solvable. They want you to solve the question. They have to, give questions that you can solve. Right? So keep these things in mind. Don't jump the gun. This is something like, an advice which is also true for PNC. Don't jump the gun and start writing things. Observe what is happening. That will help you, get to an answer correctly and, more importantly, faster. All right. So let's say this is what your algorithm should be for a generic function question. See if the function is a known one and check for any given constraints or rules that they might have given to you. This is something we have discussed. The most common sort of, known functions that we can have, which are easy to, manipulate, we have discussed so far. If not, you have to, entertain the possibility that there is a pattern. Now, how do you identify a pattern? By looking at the data. Do you have the data given to you? You have only been given a function definition. So you make the data for yourself. You put some small values. You put some, and putting values, generally you should do 0, 1, 2, 3. You should also, if allowed, you should do this -1, 0, 1 if negative is allowed. right? So these are good guesses of what to check for, because generally these calculations would not be very difficult, right? You put the values and then you should probably take the call. Should I go for a pattern, or should I just power through and calculate? Basically pattern versus brute force approach. And we will discuss this. There are 6 questions that we are going to discuss towards the end. Before we get to those, let us discuss the most probable patterns. This is something which is, honestly, might be a bit new for you. This is a revision class, but this is probably a bit new. So let us go here. Linear or arithmetic pattern. Your most probable patterns, pattern number 1, linear or arithmetic pattern. When the function definition that is given to you, it involves addition, subtraction of inputs, and the inputs are x to the power 1s only. Typically, these would grow linearly with x. They would turn out to be linear functions. For example, if you look at this, does this feel like an arithmetic mean to you? Can you guys? Yes, wonderful. You can identify this is arithmetic mean written. F of x plus f of x plus 2 divided by 2 is equal to f of x plus 1. This relationship I can extend to all, which means that the sequence, whichever x I pick, x plus 1, x plus 2, x plus 3 and so on, they are going to be in what? In AP. So when you have something like this, when you have addition or subtractions of the inputs and the inputs are in x to the power 1 only, then an arithmetic progression is a real possibility. Pattern number 2. Now you all have seen this so far, you have heard this from me multiple times. Addition is to AP what multiplication is to GP. So a geometric or exponential pattern, if multiplication is involved, either within the input or, in the way f of x is combining the value, basically outside, you might come across a situation typically when the ratios between the values are constant. For example, if I look at this, f of 2x is equal to 3 times f of x. I see that the input has been scaled, and on the output end I can see a scaling factor 3 is put outside unscaled input function. F of 2x is equal to 3f of x. Let me put x is equal to 1. I get f of 2 is equal to 3f of 1. What about f of 4? Will I get f of 4 as 3 times f of 2? And what was f of 2? 3 times f of 1. So I am getting f of 4 is equal to 3 square f of 1. What about f of 8? It will be 3 cube f of 1. Yes? So far you all follow? F of 4 will be 3 times f of 2, right? Because if you put x is equal to 2 here, you will get f of 4 is equal to 3f of 2. And f of 2 is 3f of 1. So you will get f of 4 is equal to 3 square f of 1. And you can then iteratively use this. And this gives you an idea, right? That the thing they will ask from you would probably be in powers of 2. And yes, this is a previous year question. The pattern that has emerged is that you are looking at a geometric progression. Did I ask you for f of 5 here? This is what I was saying when I meant point versus continuous domain. I could handpick the inputs that I want to address in the question and give some, answer, or give some relationship to you. In continuous, I would have to justify the existence of everything. F of 5 exists here? Yes. Is it easy to find? No. So they are not addressing that. They are only giving you f of 4, 8, 16, etc. So if they ask you for f of 2048, Your answer should be simple. Convert 2048 into 2 to the power n, and then use that n to find what appropriate power of 3 you have to use. F of 1 is something they have to give to you. Yes? Alright, let's proceed. Now this is a tricky one. These patterns would be, example that we have taken here, it is too straightforward in my opinion. We do have a question on this upcoming. If you have signs flipping or your terms seem to repeat every few values, then you get a alternating or a periodic pattern. You can get this. And here it is simple to see, right? If f of x plus 1 is minus f of x, so you get f of 1 is equal to minus f of 0. You get f of 2 is equal to minus f of 1. And once you put f of 1 as minus f of 0 here, you will get f of 2 is equal to f of 0. You will get f of 3 as minus f of 2, which is minus f of 0, which is f of 1. What is the pattern that I am seeing here? Can someone, identify? What is the pattern in the input that I am seeing? Odd inputs are giving me the same output. Even inputs are giving me the same output. So they can and they do play on this. That odd. This is also PYQ. Yes. I mean, there are as many concepts that they can ask. So most of these would be in PYQs in some shape or form. It's just that they are not addressed in this way, which is why, we have this course. Alright, so values will oscillate between a fixed set A, B, A, B, A, B, or it could be A, B, C, D, A, B, C, D, A, B, C, D. Where have you seen patterns like this? Number system, tell me. Unit digit. That is correct. Alright. Now, recursive or additive build patterns. And this is what I think you guys come across the most. When the function uses the function itself to build itself. F of n plus 1 is equal to f of n plus f of n minus 1. In a verbose way, in a written way, how will I say this? That the value at this input is the sum of the previous two inputs. Next term is addition of the last two. The typical behavior is a Fibonacci like sequence. If you guys don't know what a Fibonacci series is, again, that is not relevant here. That is not what the point is, but it is 1, 1, then the sum of last two terms 2, then the sum of last two terms 3, then the sum of last two terms 5, and so on. You should first, find first 5-6 values here in these sort of situations, and you would see, you can either cancel those terms out, or some pattern will emerge. For example, if some sum was asked for you, let's say f of 1 or f of 3 is equal to f of 1 plus f of 2, which means f of 4 is equal to f of 2 plus f of 3. I can add these two and f of 3 will cancel out. So I'll get f of 4 is equal to 2 times f of 2 plus f of 1. So these sort of principles you can use depending upon how far you have to go. Or you can actually find these values and then take a call what the pattern is. Alright. So this is the last one. A quadratic or a polynomial pattern. And this is, something you guys should be able to notice when the consecutive function value is following a polynomial pattern. For example, this. Now, this is something we have discussed previously as well. If the difference of the two values of the function is linear, then the function itself should have what power? The function itself should have a power of 2. It should have 1 greater than the difference. So your function degree will be 1 plus expression degree. And the reason being that when you write f of x as ax square plus something, or let me say ax to the power n. when I do f of x plus 1, you will get a times x plus 1 to the power n and so on so on. Where will x to the power n come from in the first expression? Here. Where will x to the power n come from in the second expression? X to the power n multiplied by a. So when you subtract these two, this will cancel out and you will be left with the term of x to the power n minus 1. So the difference is linear, then the function is quadratic. If the difference is quadratic, if this was given to you as x square plus 2x plus 3, then f of x you would have assumed as a cubic function. So how to identify this is successive differences or the of differences, they will turn out to be constant. Basically, you want to arrive at this constant. So you can either go by this approach by looking at the power of the difference, or if the values you have calculated, you should find successive differences. Alright. Now this is the final piece of advice here. First of all, random patterns can exist. Once you decide that a pattern should emerge, you should focus on finding it. If you are not able to find the pattern in 1.5 minute, all in, leave the question. It is not worth it, which brings me to the expected value of a generic function question. It is high. You can, solve it in a very low amount of time, but only if you are able to figure out the pattern. If not, you will end up spending too much time. So this is win or lose sort of situation. You should not be spending more than 2 minutes on these sort of questions, because once you are trying to find a pattern, you go into that DILR solving mode, and you will never know when those 2 minutes become 5 or 6 minutes, and then it is a disaster. So do attempt this question. We have covered most of the things that they can ask you. Guessing the function we have covered. Finding the pattern, we have covered most sort of patterns also. But even then, you should attempt it, but with the caveat that I will not hesitate to leave this sort of questions. I cannot stress this enough. You can end up spending an obnoxious amount of time on just one single question. Alright, and final advice, a lot of you like to do this, a lot of you like to do dirty rough work. If you get a composite function, something like f of g of x is this, so find f of g plus g of f whole of f. Boss, please make a table. Make a table, find f of x, find g of x, then find f of g of x, and so on. The reason, being because these would look very similar. F of g, ffg, fgf. You might end up making a mistake, which you would term to call as a silly mistake, and I would agree with you because it's a careless mistake. Secondly, if you hit a snag, if you hit a position where you don't know what to do next, you can always come back to this question and re-leverage this table. So again, same argument as we have for ratio proportion questions, right? Always make a table if you can. It is very easy to reuse it. Same argument as time and work TSD. If you make the diagram, you can always come back to it. Alright, so let's quickly jump into questions. 98 is correct. Let us observe. First of all, is this a point function or a continuous function? Have they put any restrictions on the domain? No. So it's a continuous function. However, they have given you boundaries of the different definitions as integers, and then they are asking you for an integer. So even though they have not put a constraint, they are explicitly focused on the integer aspect of things. I am leaning towards I can't guess this function, and this isn't even the biggest reason. You have f of something. F of something. Do we have a function for this? Did we discuss a function for this? No, right? So no cell here. What is it that I can next observe? Now I have to take a call between finding a pattern or calculating. You have to find f of 50. You have no starting point. The only starting point that is given to you is here. When you put x is equal to 100 and you get f of x is equal to 100 minus 2 is equal to 98. Should I make my way from 100 to 50? Can I work through 50 values in a CAT examination within 2 minutes? No. Which means there is a pattern. Now look at the question statement and try to, build an intuition. What should be the pattern? Do you get the sense that the pattern should be repetitive? It's a hunch. You don't have to justify it. And where are you getting this hunch that the function is repetitive? Here, they are linking x with x plus 4. Okay, it's a composite function on the other side. They are not giving me f of x is equal to f of x plus 4. That's not what they have given to me. In this case, you would know it's a repetitive function. But still, that inspiration can rub off. So, what was the next step? How do you identify a pattern? By getting some data points. So, you have f of 100 is equal to 98. F of 99 will be equal to f of 103. What is f of 103? F of 101. Sorry, f of 103 is 101. And what is f of 101? 101 minus 2, which is 99. So far everyone is with me, I hope. Yeah. Let's find one more value. F of 98 will be equal to f of 102. What is f of 102? F of 102 is going to be what? 100. F of 98 is equal to f of 100. What is f of 100? 98. 98, 99, 98. Do you see a pattern? Or do you see a possibility of a pattern? Yes, you do. Because when you go and find f of 97, it will turn out to be 99. And what is the pattern? Is it odd even? Yes, it is odd even. Even input is giving you 98. Odd input is giving you 99. So your answer is going to be 98. A bad question, or rather bad options, because they should have put 99 here, right? The only other possibility of an answer, they should have put it here. So the answer is 98. Were you able to follow the thought process that we developed? First, make a call, can I guess the function? Once you made that call that I can't, then you decide, should I guess or should I just put values? And when you decide that I have to guess, what are the intuitions that I can build? And then I find the data points and back that intuition. So it is a thought, there is an algorithm to this thing. All right, next question. For any natural number n, f of nx, and this is capital F, is defined at f of n times x. F of x is given to you as linear. Then what is f of 10, and the value of x is 10. First of all, and let us discuss the thought process. Can I guess the function? Can I guess this? No, I can't, because you have so many composite functions sitting within themselves. I can't guess it from the get-go. Should I brute force this or should I focus on the pattern? Now that I've decided I can't guess the function, what should I do? Pattern. Okay. This is a difficult call to take. You could have calculated. I mean, you only have to calculate till 10th step. And let's say you have just 5 minutes left in the exam and you decide, I will do this one question and I will do it correctly. You might feel tempted to guess. What is stopping you from guessing? What is stopping you from going for the brute force method? Do you understand that getting from f of 10 is equal to 35 to options like these, how many such large values you will have to calculate in between? Right? So the only possible choice is pattern. All this thought process that I just described to you happens within seconds. Right? And that is what we are trying to aim at. I think you are right, Priyam. I think you are right. So the idea is f of x is equal to 5 plus 3x. Now f2x is going to be 5 plus 3 times 5 plus 3x. Do you notice how I have not put x is equal to 10 right now? Because I am clear that the pattern that I will get at will be based on x and not based on the actual value. The input will just complicate things for me and make it more calculative for me. So this turns out to be 5 plus 3 into 5 plus 3 square x. I can club these two, but I will decide not to. I would rather focus on what is the next step. And next step is going to be 5 plus 3 times 5 plus 3 into 5 plus 3 square x, which will give me 5 plus 3 into 5 plus 3 square into 5 plus 3 cube into x. Do I see a pattern? Do I see a pattern? And what is the pattern? Is f of nx is equal to 5 into 1 plus 3 till 3 to the power n minus 1 plus 3 to the power nx? Is this something that I know? Is this something that I know the value for? It will be n minus 1, right? It will be n minus 1 and not n. The simplest way to do that is just check for n equal to 1 that is given to you. When you put n equal to 1, you should have 5 into 1. So 3 to the power 1 minus 1 plus 3 to the power 1x, 3x. So you have guessed your function. Now I could not guess it from the get go. That is fine. I used the pattern. Just after the third step, I guess the function. Now I just have to put the value. You just replace this with the sum of GP. That is something you know. You have your answer. You just write x here. Clear? All right. So this we have discussed already. Let's move to the next one. All right. Observations. Can you guess the function? Again, it's a subtle call. Feels like I can guess it because I did see a lot of these things. I saw f of xy is equal to f of x into xy. I saw f of xy is equal to f of x plus f of y, but I did not see both of these together. And the reason for that is that the function for that guessing is complicated. You can't guess that. So let's say guessing is out of picture. Now look at what they have asked you. Is this something that you can calculate manually? I mean, should I even ask? 1,60,000? No. So I have to go for a pattern. What pattern can I have? There are two hints for you. Hint number 1. Prime number p, they have given me the function value. So it has to do something with prime numbers. Hint number 2. All the options are 2 to the power something minus 1. This is 2 to the power 10 minus 1. This is 2 to the power, I think, 12, 11, 12, 13 minus 1, if I'm not wrong. This is 2 to the power 11 minus 1. Yeah, this is 2 to the power 12 minus 1. And so on. This is 2 to the power 13 minus 1. So the answer will have to be 2 to the power n minus 1 format. So let us build upon this. F of a prime number is equal to 1. We will have to convert this into primes. That much is clear now. But let us also, let us try and get to it in a better way. F of P into P is going to be what? F of P into F of P plus F of P plus F of P. Is that correct? Which gives you F of P square is equal to 1 square plus 1 plus 1, which is equal to 3. What is the next thing that I should test for? Alright, this is the relationship that is given to you. Let's write it in a neat manner. Yeah, you are getting F of P square is equal to 3. Let's find F of P cube now. So P into P square is going to be F of P into F of P square plus F of P plus F of P square. What is F of P? 1. What is F of P square? 3. What is F of P? 1. What is F of P square? 3. This is 7. Do I see a pattern now? Can I say F of P to the power n is equal to 2 to the power n minus 1? Can I say that? Does this check all the 2 hints that I had? Yes, it does. It checks all the 2 to the power n minus 1 I am able to make, and I am able to use the prime numbers. So basically I found F of P square as 3. I can write 3 as what? 2 square minus 1. I then used P square and P to find F of P cube. That I got as 7, which is 2 cube minus 1. At this point I can make an educated guess. And that is exactly what we have done. Alright? Yeah. Priyam, you have another way you can unmute and explain to us.
Sir, I was saying both sides add 1.
Okay.
So it would be factorization of f of y plus 1 and f of x plus 1. That would be g of x means, and it is given that it is something prime. So it would be plus 1, so 1 plus 1 would be 2, something in power of 2.
Okay. We arrived at this, this is the second method. You add 1 on both sides, which will make this factorizable as f of x plus 1 into f of y plus 1. This is f of x y plus 1. Right? So what am I getting from here? If I can write this 16,000 as products of prime numbers, then you will get fp is equal to 1 is given to you. So this would be 2 to the power something into 2 to the power something, and then this minus 1 will come to the other side. That's what you are saying, Priyam?
Yes, sir.
Yeah. Alright, fair enough. All those things. I hope the algorithm that we developed, it was tested well here. Take your calls, and then when it comes down to guessing, figuring out the pattern, we use the information that is given. Next question. Alright. First of all, sum of all possible values of x for which f of x is equal to 3. Sort of feels like I do have to find what f of x is going to be. Now, the trick here is something we didn't explicitly discuss, and for that reason we had a slide that random patterns can exist. You have to be observant. This is f of x plus 2 times f of 1 by x is equal to 3x. If I replace x with 1 by x, you will get f of 1 by x plus 2 times f of x is equal to 3 by x. If you replace x by 1 by x in both sides. Now you just have to multiply this whole thing with 2 and subtract. This will directly give you f of 1 by x will cancel out, and this will directly give you the value of f of x, and then you put it equal to 3 and find the roots. So Not a difficult question at all. But if you don't put x as 1 by x, it's going to be very difficult. It's going to be a difficult question in that sense. Yes? We got this inspiration from this line, that sum of all possible values of x for which f of x is equal to 3 means that I do have to find the function. I do have to find the function and equate it to 3. And then I look at this equation and then I realize that I do have control over the input because they have said non-zero. Non-zero means what? Why should I, explicitly mention non-zero? So that I allow you to do 1 by x. This is same way as saying non-negative so that you can apply AMGM. Clear, Adya? Yes. Okay. Question number 5. F of x plus f of x minus 1 is equal to 0. G of x is equal to x square and f of x square minus x is equal to 5. Then I have to find this sum and this sum. G of x is given to me directly. Can I guess the f of x function here? Can I guess the function here? First of all, if I am guessing, what would be, the thing I will look for? Polynomial, right? Yes, but what is the difficulty in this red box? What is the difficulty that I am facing? What is causing me trouble? The thing that we showed was for difference. It was not for addition. This plus sign is going to cause issues, which means I can't guess. If you remember, what we had discussed was this, that when the consecutive function values, this difference follows a polynomial pattern. Now that is something which is not happening here. You have a plus sign. So let us start. You have f of x into x minus 1 is equal to 5. Let's find f of 1 is equal to f of 0. F of 1 plus f of 0 minus 1 is equal to 0. Now this gives me f of 1 is equal to 1 minus f of 0. I can put x as 0 here or x as 1 here, right? Let's put x as 0. I will get what? F of 0 is equal to 5. So f of 0 is equal to 5, which means f of 1 is equal to minus 4. Correct? Now what is the next thing I will observe? Do you see x and x minus 1? Do you see the possibility of a pattern here? What are x and x minus 1? If x minus 1 is something, then what is x? Is it the next term? Or is it alternating terms, odd, even? If x minus 1 is odd, then x is going to be even, and so on. Basically what they are saying is f of product of two consecutive numbers is going to be 5, which is something I will use, and you will then find that this is again an odd even pattern. F of 2 will turn out to be 5, f of 3 will turn out to be minus 4, and so on. Correct? So then you are clear. Then you only have to find f of g5 and g of f5. Okay? I mean, if you want, we can go and find what f of 2 is going to be. But I mean, the idea is this. Alright, last one. Okay, can I guess the function? No chance at all. Because point domain, they have separated the values. Okay, Pattern or guessing. Can I guess? Can I find 2021st term? Not at all. I can't go with brute force method to find. So there has to be a pattern. Can I see the pattern immediately? No. Which means what should I do? I should get myself some data points. So x of 0 is equal to 1, x of 1 is equal to 2, x of 2 is going to be equal to what? 1 plus 2 by 1. So x of 2 is going to be 3. What is x of 3? 1 plus 3 divided by 2, that is 2. What is x of 4? 1 plus 2 divided by 3, that is 1. Seems like I am on the cusp of a pattern. Let me just satisfy myself by finding x of 5. What is x of 5? 1 plus 1 divided by x3, which is 2, that is 2 by 2. Sorry, x5 is going to be what? 1 plus x3, yeah, x5 is going to be 1. What is x6 going to be? 1 plus x5 divided by x4, that is 2. Now 1 and 2, the pattern has started to repeat. So 1, 2, 3, 2, 1, 1, 2, 3, 2, 1. So in blocks of 5 your pattern is repeating, which means till x of 2, 0, 2, 0 you will be consumed. Or actually this is starting from x is equal to 0, right? So you make the blocks accordingly, take the unit digit. Yeah, so 2017 will be 1. So a pattern will be till 2019. So your answer will be x of 2021 is equal to, come on, 2. Alright folks, so that was it for today's class. We saw generic functions, difficult topic even after going through this class, but at least now you do have a plan. If nothing else, that plan will help you save some time on these questions, because you have an algorithm to work on. Right, as usual, the quiz for this will be shared soon, and you can practice that, and the solutions will also be posted for you. Alright folks, thank you. You have a wonderful weekend ahead.